One of the realities of being a software developer is it's not just about the tools and the code and all the fun stuff. It's about an organization that's putting together an application. And when we start talking about organizations, we start talking about processes. And so this class is going to start with defining what is software process and how does it play into your job as a worker within the IT field eventually here. Whether you're going to be a coder or a tester or a system administrator or security expert or whatever, networking, whatever your role is, it's going to fit into the process somewhere. So what is a process? Well, a process acts as either a guidepost for people. Basically, it's a way of teaching you how software is built in an organization. It can be as detailed as a manual that's step by step. What do you do to build and release software? And ideally, it gives you instructions from the big tasks that you're going to do, possibly all the way down to exactly how to fill in certain pieces of paperwork. Each different process has different levels of effort. Each of the process has different levels of detail, and your corporation is going to figure out what level of process they want to follow. Everybody follows some sort of process, even if you're kind of making it up as you go. And so the idea is if you can document that process, you can really share the details with your peers. The goal for that, though, is to act as a watchdog, to set a minimum bar for how good the results are going to be on a project. We're going to be able to measure the quality of what we're building and basically keep people accountable for, I want this to be some level of good outside of there, and be able to ensure that quality. And so I want to move away from this project's going to be great if we have great people into the idea of a standardized approach. So think of it this way. If I'm creating a band, I don't want to live off of a really great drummer or a really amazing saxophone player. I want everybody in the band to have a certain level of skill so we sound good overall. If I'm doing a sports team, I don't want to deal with one or two great athletes. I want a system by which we play offense or defense or whatever your sport involves in order to make sure we have some quality for everybody on the field. So people do this software stuff every day. What's the point of formalizing it? Well, the idea is when we formalize it, we absolutely do take longer. The steps are going to take longer to get the job done. And you might also say, like, wait, what about creativity? What if I see a better way to do it along the way? Absolutely. In process, it's going to limit some of the things you might do that might optimize things or might do things a little bit differently. It's not to say that those things are impossible. It's just saying by default, we want to capture what you're doing. We want to document what you're doing. We want to, if we're going to change the process, there's a process called tailoring, we just want to write down what you did so other people can capture those good ideas. We can both know what you did, but also use those ideas going forward. So by no means is it meant to totally stifle innovation or to totally slow people down. It's just meant to capture and approve what we're going to be doing. So how do we do that? How do we capture it? How do we write these things down? Well, at the highest level, most of the software projects look the same, and that's how everybody pretends they're doing process. We have some sort of definition phase where we say, what are we going to build? And we constrain the product that we're going to build. We have some sort of development phase where we write some code, we test some code, we do a bunch of stuff, and then often forgotten is the maintenance phase where after we release the code, we are out there trying to figure out, well, is it working? Is it doing the right thing? Is there some tweaks that need to happen? Is it performing well? All those different things. Those are part of the software process as a whole as well. And so breaking it down that way, we can go more detailed than that. These are just high-level cuts of this. We want to be able to get better. We want to be able to talk better about what's going on in our project. So the way we do that is within those phases, we define activities. When we talk about high-level process definitions, we're going to define activities. And an activity is the things that are going to be done. So things like requirements, design, testing, those big level things that you'll see in the syllabus of this code are high-level activities. We might break those down a little bit further. They don't necessarily have to say that high level. We might break those down into requirements elicitation, requirements documentation. So an elicitation could be something by I go around to different people, different stakeholders and ask, well, what do you want from this? What would make a good system? And then documentation is how do I formally capture those and approve those and move those along. So it's not always every project is requirements test, requirements design, code test, release. There might be sub-activities. Now, the activities is just a high-level description of what you're doing. The methods is how we do that work. So the methods is the next level of definition we're going to go into there. We'll talk about this more in a second. But how do we achieve that work? And then the artifacts is what is the results? What are the documents that we're creating that capture these different work products that we're going to move along with? So at the high level, as we said, examples of these activities is we have project management activities. Those are almost always broken down to project planning, risk management, schedule reporting, sorry, my brain's slipping here, post-mortem at the end of the project. Those are different types of activities that would happen that would fall under the project management category. Then we capture requirements, we design, we do implementation or coding or however you want to call that, and then testing. Releases could be out there. We have a process in my company that we is after it, and so we have a maintenance phase is what we call it. It's basically a warranty phase that it comes in. That's how we refer to it as. And so each of these top level activities probably are the same across every project. We might do more or less inside of these activities, but this level of activities should be the same ideally on every project. Now, the next behind that then, that by having those activities, it gives us a structure by which we know our projects are going to be conducted. Whether it's a small project or a big project, I know I'm going to have things like project management, the orange tasks over the top of everything. And then each of the purple boxes is the things I can flow in. Now, where they get scheduled and what little pieces are inside of them, what gets included, it might vary. If I have a web development project, it might be different than if I'm doing something that's a database optimization project, which is probably something different than a network optimization project. But in general, we want to define the requirements, we want to design what we're going to do, we want to implement that, and we want to test what we've done. So those are high-level things to ensure quality. The methods then is what takes those activities and gives them teeth. It describes what do you do in each one of those activities, or maybe sub-activities going on. So examples of these, I do estimation, I do scheduling at the project level. Obviously, I document requirements. So how do I do that? Well, there's different methods. Some projects might use use cases. Some might use a JAD session. Some of the stuff we'll be talking about when we get into the discussion boards here. So each of these different things tell how do we do it. It normally includes some sort of template, some sort of rules, some sort of standards by which the work is going to be completed. But the results of the methods tend to be artifacts. The artifacts is what I walk away from it with. It could be the project schedule. It could be the software requirements or the design. Code is a definite artifact that gets created. You might not think of it as such, but it's a document that gets created and that you do that. Test plans. That's one thing. And then the planning phase is one activity. A different activity is actually executing the test. So off of executing the test, I have bug reports. I have test results. I have approval letters to say, yes, we all agree that this project is ready to go. All those things are artifacts that ideally are formalized and captured by the process. Not every company goes to this level of detail, but some companies do more. This is what you'll be discovering a little bit when you do that initial discussion board. You're going to look at different types of processes. You're going to compare them and look at the different rigor. It's not listed in the assignment. I've put some additional details in there about very formal processes such as MIL-STAN 498 or Boeing D6 or DO-178B. These are different high-level processes for building weapons and airplanes and different high-level mission-critical systems, spaceships, that ensure quality when we're going through that. And in those cases, there's a lot more documentation. There's a lot more expectations. And so that's what we're going to get into as we go through this course. We're going to break down these different process approaches, and you're going to go through this high-level planning activity. We're going to build a project through the activities we do here by doing requirements, then design, then test plan, then pulling it all together with some high-level planning activities. And that's the goal here, is so you can at least see this side of the fence. So as you work either in this role or even not, you can support the people of this critical project activity of defining and following a process.